In elementary science, we are taught that light always travels in straight lines. But this is not strictly true. Uninterrupted light waves may travel in straight lines through empty space, but if light is partly blocked by a barrier or passes through a narrow slit, a small hole or some other aperture, then it is diffracted. The light passing beyond the barrier spreads out in new directions, forming a complex pattern of bright and dark bands known as a diffraction pattern. The exact form of the pattern depends both on the wavelength of the light and the size and structure of the aperture or object. In everyday life, we are not normally aware of the diffraction of light. This is because to produce significant diffraction effects, the dimensions of a diffracting object must begin to approach those of the wavelength of the incident wave. Visible light has wavelengths in the range 400 to 750 nanometers, and so comparatively small apertures and objects are required to produce observable diffraction. You can, however, see diffraction fringes if you squint through your eyelashes at a street lamp. The coloured fringes reflected from the microscopic pits on a compact disc also result from the diffraction and subsequent interference of light. Diffraction is much more than a scientific novelty. The diffraction of light limits the ultimate magnification that can be achieved by microscopes and telescopes, and an understanding of diffraction is needed to optimize the performance of these instruments. The device called a diffraction grating is the central component of the spectrometer, an instrument used to analyze light and other radiations. Spectrometers are used in almost every part of science, from biology and chemistry to materials science and astrophysics. The diffraction of X-rays is used to reveal the structure of matter at the atomic and molecular scale. Indeed, one of the great scientific breakthroughs of the 20th century, Crick and Watson's discovery of the structure of DNA, was made with the aid of X-ray diffraction patterns, which are, in principle, formed in exactly the same way as the optical diffraction patterns on this disc.